Hello guys, my name is Nikhil. I'm from Sri Venkateswara College of Engineering. My SIN is 22CS087. Today I'm presenting my video assignment. My topic is an algorithm to design finite automata. Introduction to finite automata. Finite automata are mathematical models used to represent and control sequence of operations. They are essential in computer science for tasks such as text processing and lexical analysis. Understanding their design is crucial for automating design process. What is finite automata? A finite automaton consists of states, transitions, and acceptance conditions. It can be classified into two types, deterministic DFA and non-deterministic NFA. Both types serve similar purpose but differ in how they process input. Components of finite automata. The primary components include states, input, symbols, transmission functions, and initial and accepting states. State represent the status of automation at given any time. The transmission function defines how the automation moves from one state to another based on input. The design algorithm overview. The design algorithm for designing finite automata follows a synthetic approach. It starts with defining the language that the automation should recognize. The goal is to create a state diagram that accurately represents this language. Step 1. Define the language. Clearly outline the specific patterns or strings the automation should accept. This involves identifying the alphabet and the rules governing acceptable string. A well-defined language serves as the foundation for the automation design. Step 2. Identify states. Determine the necessary states based on the defined language. Each state represents a point of a progress in processing input string. Ensure to include accepting states that simplify successful recognition of input. Create transition function. Develop transition function that dedicate how the automation moves between states. These functions based on the input symbols defined in this language. A clear transmission diagram will help the visualize the automation operations. Step 4. Initial and accepting states. Design at one initial state where the automation begins processing input. Identify one or more accepting states that signal successful string recognition. This step is crucial for the automation to function correctly. Step 5. Draw the state diagram. Create a visual representation of a state and the transitions using a state diagram. Again, this diagram helps in understanding the flow of operations within the automation. Ensure that all transmissions are clearly marked to avoid confusion. Step 6. Testing the automation. Once the auto design is complete, test the automan with various input string. This helps verify whether the automaton correctly accepts or rejects string as intended. Adjustments may be necessary based on testing outcomes. Optimization. Analyze the state diagram for any reducent states or transitions. Simplifying the automaton can improve efficiency without losing functionality. An optimized automaton is easier to implement and maintain. Conclusion and applications. Finite automata plays a visual role in numerous applications, including compilers and network protocols. Mastering the design algorithm enhances problem solving and programming skills. Continued practice in design finite automata will lead to greater proficiency in automata theory. Thanks for watching this video. Bye bye.